Welcome to another exercise for the workbook statistics, this time with an exercise on the exponential distribution. Here our task is as follows. The number of points reached in a math exam is exponentially distributed with a mean of 61 points. So this already tells us, we are working with an exponential distribution here and we have a mean of 61. Well, if we work with an exponential distribution, we know we need this factor lambda. This factor lambda is directly related to the given mean of our distribution, lambda being the inverse of the mean. If I have a mean of 61, I know that lambda will be 1 divided by 61. So I already have all the parameters for the distribution. Well, therefore, we only have to state our tasks. First one being, what is the probability to get at least 50 points and thus pass the exam? At least 50 points. This translates in the points being 50 or larger. So it's x larger or equal to 50. The second part then, determine the probability of getting a 2.3, so the mark 2.3, which would translate into getting something between 75 and 80 points. So here we have to calculate actually two probabilities. Well, let's take this step by step. Starting with part A, we already know it's exponential distribution. We know we want to calculate the probability that we get at least 50 points, so that the number of points is larger or equal to 50. Since it's a continuous distribution, all the formulas we have work with x being smaller or equal to. So we translate this by calculating the counter probability, which is 1 minus, and then we can turn this sign around. So instead of going with this one, we go with 1 minus probability of x being smaller or equal to 50. For this, we can then use the formula we have. And for the formula, as I mentioned before, we also know that the average is 61, and thereby the lambda is 1 divided by 61, or if I round this, 0.0164. So I can simply calculate the probability I want to have by going with 1 minus, and this probability. This would actually be 1 minus e to the power of minus lambda k. Since I have the minus before this, so I have 1 minus 1. Minus minus gives a plus at this point. And I see as well the one here, they cancel each other out. So I'm left only with the term e to the power of minus lambda k. Lambda I know, that's the 0.0164. K I know, that's the 50 here. So I can insert those two values, get e to the power of minus 0.0164 times 50. Put into the calculator gives me a result of 44.06%. So that's the chance of passing the exam. Well, let's continue with part B. Here, again, we have an exponential distribution, and we wanted to know the probability of getting somewhere between 75 and 80 points. We can do this very easily by first calculating probability of being smaller than 80 points and subtracting the probability of getting less than 75 points, leaving us with the part in between those two numbers. So we have to calculate two probabilities separately using, as before, our mean and the resulting lambda. So if we insert this into our formula, the first part gives us 1 minus e to the power of lambda times k, k here being 80. Then minus 1 plus e, because again, this minus interacts with the 1 and with the minus here giving us plus e to the power of minus 0.0164, the lambda, and the k being 75 from here. We see this one and that one cancel each other out. We just have to calculate the two expressions with the exponential function. This point being this part here, 0.7307. I just wrote this that I have the plus 1 first, minus 0.7277 being that one. I subtract the second from the first, giving me a total result of 2.3%. So the chance of getting a 2.3 is actually 2.3%, which is just coincidental. Well, this already concludes this exercise, so I hope you enjoyed it. I say goodbye and see you next time.